Hey guys, welcome back. Today I'm going to be doing an update on Dragonfly. Not going over the charts. I'm going to be going over the 10k form that they released on March 30th. I specifically highlighted their uh, trucking APU information and their solid state battery information. So that's what I'm going to be going over today. And I hope this is insightful. I certainly have gotten a lot of information out of this forum. Um, if you want to know when they're going to be producing dry or solid state batteries, dry electrode uh, lithium ion batteries, I'll just spoil it. It's going to be a minute. They plan on starting to produce the pouches in the beginning of 2027. So we have about a year, and then they're scaling up the production of the pouches by the third quarter of 2027. So then we have basically a year and a half until then. But they are currently making little cell, what do they call it? Like nickel size cells, so little small batteries of the dry electrodes. They're currently making those, and they are basically refining their process on those. Is what I got the takeaway from that is. So let's just go into it. So right here we have the 10k form of Dragonfly Holdings Incorporated. I'm just gonna scroll down. I have the information that I want to go over highlighted. Here in the green is going to be the trucking APU stuff. So I'll just go and read over this. Drawing up on our success in collaborating with RV and marine OEMs, we have begun expanding into the heavy-duty trucking market. We are leveraging our expertise in designing and supporting lithium-ion storage systems to tailor solutions meeting specific requirements to fleets. These solutions have been adopted as factory options, demonstrating their value propositions for truck fleets seeking to reduce fuel costs, complying with anti-idling regulations, and enhancing sustainability efforts. Wow. So good news on that is that these have been adopted as factory options. So these are things that can be selected into the trucks when they are ordered. They're not, they're not going into every single truck, but as the trucks are ordered through the companies that want these long haul trucks, they will be put into. So that is going to be a consistent revenue source as they are getting ordered. So that is great news. I'll continue. This strategic approach has led to expanded adoption of our products by large fleet operators, including Highway Transport, Stevens Transport, and Warner Enterprises, as these customers have progressed from initial evaluations to broader system developments. In parallel, we continue to engage in pilot programs with additional fleets, which remain an important driver of a future customer adoption and expansion opportunities. We also support fleet adoption through industry collaborations and thought through leadership, including co-authoring a technical white paper with Packard focused on electrification and energy storage applications in heavy-duty trucking. So that is great news. We already knew about the Highway Transport, Stevens Transport, and Warner Enterprises deals, but the fact that they told us that there is more companies in the pilot program for future customers is great news for large order of their APUs. And then I think I got one more thing highlighted in green for the APU heavy duty trucking. And here it is. The heavy duty truck market encompasses a broad range of vehicles designs for extensive commercial and industrial use, such as long haul transport, construction, and logistics. Even in the midst of historic freight recession, more than 200,000 Class A units sold in 2025, a surge in projects as the demand for more efficient, sustainable, and reliable transport solutions grow. The use of auxiliary power units, APUs, in heavy-duty trucks is becoming increasingly sufficient. APUs provide an alternative energy source for powering onboard systems and maintaining a cabin comfort during rest periods without the need for the main engine to run, thereby reducing fuel consumption and emissions. Additionally, the market opportunity extends to electrification of the transport refrigeration units, so TRU, and on trailers and smaller class refrigerated vehicles, which are crucial for the cold chain logistics sector. This shift towards electrification is driven by the need for more sustainable and efficient cooling solutions, reducing the carbon footprint and refrigerated transport. The expansion of global trade and continuous push for lower emission standards are driving the demand for heavy-duty truck equipments with APUs, as well as the electrification of TRUs. Highlighting a considerable market opportunity, this trend emphasizes the potential for advanced battery technologies not only as an environmental solution, but also as a competitive advantage in heavy-duty trucks and refrigerated transport markets, offering a sustainable retrofitting market penetration opportunity for battery manufacturers and suppliers with the requisite expertise and product offerings. So we already knew that Dragonfly has been producing APUs and selling APUs to trucking companies, but for the transport refrigeration units, that's new information to me from this form. I don't know if Dragonfly has that product available yet, but that sounds, if they're putting this into their form, that sounds like they may be working on a refrigeration or a reefer, I would assume, for trailers and short box trucks. So that, that's just another product to go into their line for more sales. Overall, great news. I believe that this sector is going to be a big carrier of Dragonfly for the next year. So I can't wait to see what the numbers are like throughout the year and how they produce these APUs for the trucking industry. So I'm going to scroll back up and we're going to get back into the dry electrode manufacturing. Let me get a drink of water real quick. Ooh, much needed. So let's start. To augment our core lithium-ion battery pack business, we rely on research and development. The team has successfully developed innovative manufacturing processes for dry electrode manufacturing of lithium-ion cells and continue to develop efforts relating to next-generation solid-state technology. Since our inception, we have built a comprehensive patent portfolio around our proprietary dry electrode battery manufacturing process, which eliminates the use of harmful solvents, energy-intensive drying ovens compared to traditional methods. This translates to significant environmental and cost benefits, including reduced energy consumption, smaller space requirements, and lower carbon footprints. Moreover, our solid-state technology in development removes the need for liquid electrolytes, thereby addressing safety concerns related to flammability. Our unique competitive edge lies in the combination of solid-state technology with the scalable dry electrode manufacturing process. This enables the rapid production of cells having an intercirculation anode like graphite or silicon, unlike many competitors reliant on less stable lithium metal anodes. We believe this design offers superior cyclability and safety, serving as a key differentiator in the energy storage market. Furthermore, internal production of both conventional and solid-state cells streamlines our supply chains and enables the vertical integration, ultimately driving down production costs. So that right there is a main argument on why we need dry or solid-state batteries. It is cheaper to produce by just the core energy consumption to make the batteries. So yeah, let's move down to the next one. Our adjustable markets. Our adjustable markets are areas with significant growth potential that we position to penetrate as consumers turn towards LFP and other lithium-ion batteries as replacements for traditional lead-acid batteries. As these medium and long-term markets mature, we intend to deploy our solid-state technology once developed, while concurrently continuing to further displace the incumbent lead-acid technology. So first market, emergency and standby power. Demand for reliable emergency and standby power sources is expected to continue to drive demand for efficient power storage for residential, commercial, and industrial uses. Power outages in the United States cost an estimated $150 billion per year, according to the Department of Energy, increasing the demand for uninterrupted power sources. The need for reliable energy and standby power exists in both hazardous and non-hazardous environments, and is particularly acute in areas where the existing grid service is subject to intermittency or is otherwise inefficient, including as a result high peak electricity usage, grid and related equipment age, or severe weather and other environmental factors. LFP batteries are able to offset grid-related intermittencies and inefficiencies and assist in providing grid stabilization. Importantly, LFP batteries achieve these benefits in clean, reliable, and safe manner by supplementing or reducing the use of fossil fuel backup generators. Next one is data centers. Data centers have been a strong growth in recent years, with over 5,000 data centers in the United States as of September 2023, according to Statista. Consistent technological advancements and larger amounts of data generated and stored by companies for increasingly larger periods of time are driving growth in the importance and the amount of physical space dedicated to data centers. As software companies such as Google and Oracle continue to develop new technologies such as artificial intelligence, data centers where the computer and storage function are co-located also continue to grow. As the industry seeks to cut operating costs, become more efficient, and minimize dedicated physical space, we expect there to be a shift towards light, compact lithium-ion batteries that can reduce overall cost and provide a reliable power supply without sacrificing performance. Lithium-ion batteries are designed to operate in environments with high ambient temperatures that incumbent energy storage methods such as lead acid batteries. This ability for lithium-ion batteries to withstand and operate at higher temperatures can also reduce cooling costs. On-grid storage is the next adjacent market. On-grid energy storage is used on large-scale platforms with electrical power grids in conjunction with variable renewable energy sources, such as solar and wind projects. These storage units, including large-scale stationary batteries, store energy with electricity is plentiful and discharge energy at peak times. When the electricity is scarce because of the low cost of fossil fuels, the adoption of large-scale batteries has been slow. However, according to U.S. Energy Information Administration 2021 report on battery storage in the United States, lithium-ion battery installation in large-scale storage grew from less than 50 megawatts of energy capacity annual additions in 2010 to approximately 400 megawatts in 2019. As lithium-ion battery production scales, the related cost of storage lithium-ion batteries will decline, and the cost of renewable energy is expected to approach 5 cents per kilowatt, which is the amount required to be cost competitive with the price of power from the electrical grid. We believe our ability to cost effectively deploy and manufacture LFP solid-state batteries will position renewable energy projects deploying these batteries in grid parity sooner. So that was a lot to take in, but these are three major markets that are going to benefit from the existing LFP batteries that Dragonfly makes and their future solid state batteries. And yeah, that's where their solid state batteries is going to be deployed. So let's scroll down. Commercialize our dry electrode cell manufacturing technology. We have developed and continued to advance our proprietary and patented dry electrode cell manufacturing technology, which is designed to enable the production of lithium-based battery cells across multiple chemistries using a less capital-intensive and more energy-efficient process than conventional wet coating methods. The dry deposition process in chemistry agnostic and supports manufacturing in a smaller physical footprint, continuing to lower total production costs. An independent third-party assessment found that this dry electrode manufacturing approach has the potential to become more scalable, cost-efficient, and environmentally sustainable than conventional slurry-based processes. We have demonstrated the ability to manufacture both anode and cathode materials using this process and have produced sample cells incorporating FASFA-free binders and automotive-grade electrode loadings. Ongoing development efforts are focused on process optimization and equipment scaling to support future commercial deployments. Develop and commercialize solid-state technology. We believe solid-state technology presents a significant advantage to all products currently on the market, with the potential to be lighter, smaller, safer, and cheaper. Once we have optimized the chemistry of LFP solid-state batteries to enhance conductivity and power, we intend to scale up for mass production of separate solid-state batteries for various applications and use cases. So, basically, to to summarize right there is the solid state battery is going to be more cost efficient, it's going to be more scalable, and it's going to be more environmentally friendly. That's basically what it is, and cheaper as well. So scroll down a little bit. Dry electrode manufacturing technologies. Since our inception, we have been developing proprietary dry electrode manufacturing processes for which we have issued patents and pending patent applications where appropriate. Dry electrode manufacturing eliminates the use of toxic and expensive solvents and energy-intensive drying ovens in the cell manufacturing process. In turn, reduces the energy storage, space requirements, carbon footprint, and overall cost as compared to conventional slurry-based methods. Furthermore, the manufacturing technology and chemistry agnostic, meaning it can produce battery cells across a variety of different chemistries and application use cases. In 2023, we completed the construction of our dry electrode manufacturing pilot line, demonstrated the ability to produce anode and cathode electrode tapes at scale using the manufacturing process. We have developed sample cells for prospective customers across a variety of chemistry and end markets, and are designing equipment for scaled production of full cells. Solid state cells. LFP batteries are not without their disadvantages. While less flammable than other chemistries, the existence of a flammable liquid electrolyte still possesses safety risk. Like all liquid-based lithium-ion batteries, LFP batteries have potential to produce solid lithium dendrites, cyclical-like formations which can pierce the physical separators in LFP batteries, which are necessary in LFP batteries to separate the positively charged liquid electrolyte from the negatively charged liquid electrolyte, and which over time will degrade the performance of LFP batteries and potentially result in fire-related risk. The next phase in development of lithium-ion batteries is solid-state cell deployment, which contains a solid rather than a liquid electrolyte, eliminating many of the current disadvantages to LFP batteries while increasing the safety of the battery cells. We believe the deployment of our solid-state technology will provide us with unique competitive advantage compared to lithium-ion technology, where lithium ions cross a liquid electrolyte barrier between a battery anode negative electrode and cathode positive electrode. Solid-state batteries aim to use solid-state electrolyte to regulate the lithium ions. As a battery charges and discharges, an electrochemical reaction occurs, creating a flow of electrical energy between the cathode electrolyte and anode as the electrodes lose and reacquire electrons. In addition to the use of non-toxic electrode components, the removal of a liquid electrolyte will eliminate the risk of fire, making solid-state cells inherently safe. The move to a non-liquid electrolyte also means that solid-state batteries will be on advantage, smaller, lighter, and lighter than existing lithium-ion batteries. The process for manufacturing our solid-state cells is described below. Man, it's a lot. I normally don't read this much. Ooh, okay. At least out loud. So scrolling down, research and development on the solid-state batteries. Our research and development team has built up efforts to support two main narratives: scale up our patented dry electrode process for cell manufacturing, and two, the advanced manufacturing of solid-state lithium-ion batteries. We believe the dry electrode process can be leveraged to help us vertically integrate from a pack supplier to a cell supplier, positioning ourselves for long-term competitiveness in the given geopolitical, economic, and technological landscapes. Our initiatives in dry electrode process results in reduced manufacturing costs, CO2 equivalent, and factory footprints, while eliminating the need for solvents like NMPs. A third-party assessment conducted by Sphere Energy confirming these benefits have been completed in the first quarter of 2024, relating to cost efficientness and sustainability of our dry electrode battery manufacturing process. The Sphere Energy assessment concluded that our dry electrode battery manufacturing process resulted in a 9% reduced carbon footprint of cell manufacturing, with non-toxic NMP solvent required, resulting in sufficiently more sustainable process. This sustainability advantage is further augmented by a 71% reduction in energy use during electrode manufacturing using our process. Compared to standard cell manufacturing operations, by removing the need for large and expensive drying ovens, our manufacturing process requires 22% less square footage. The accumulation of these advantages results in a 25% reduction in emissions from energy use, making our manufacturing process more sustainable and more environmentally friendly as compared to conventional manufacturing methods. In addition to the energy savings, the cost assessment found our process to be highly cost effective, with an estimated 5% savings depending on cell chemistry. Our process related costs compared to conventional methods, importantly, savings were calculated without the additional cost benefits provided by domestically manufacturing battery cells as Inflation Reduction Act credits. So, what I just read basically comes down to right here. The manufacturing of a solid state lithium ion battery saves the whole industry 5% to manufacture these batteries than compared to a standard lithium ion battery. So now we're going to get into where their deployment of these batteries come into. In comparison with traditional manufacturing methods, our patented process leverages two off-the-shelf technologies to deliver the stated cell manufacturing benefits: spray drying and electrostatic powder coating. Technical risk is reduced by using off-the-shelf equipment, and both unit operations continue to be optimized in 2025. A new set of spray dryers has arrived at our facility in the second quarter of 2024, enabling us to produce larger volumes of material for electrode coating lines. However, we have delayed the deployment of these spray dryers until at least the third quarter of 2027, as we focus on designing larger scale electrode coating equipment. So what they just told us there is that they bought a new spray drying and electrostatic powder coating like machine, but they haven't deployed it yet, and they aren't planning to deploy it until the third quarter of 2027. Here we have the images of what their process of the dry electrode cathode and anode look like. I've taken some time to look at this, and from my assumption is that they have their anode their anode casting, powder casting pretty optimized. I don't see too much of a difference from the industry slurry cast. So I think where their main focus on is the cathode process. As you can see, there's a lot of empty space here compared to the industrial slurry cathode, where there's not a lot of empty space here. So I'm guessing when they refer to optimization is to have this equally spread out on the cast and not clumped up in what looks like formations. So that's has to be where their optimization is going, because their anode process looks very similar to the current industry process. I'll continue reading. Now, our solid-state technology continues to progress as we qualify new chemistries and refine the dry electrode process for solid-state applications. Currently, we're recycling solid-state coin cells, so small little batteries. Although we have delayed the production of prototype pouch cells until at least the beginning of 2027. These cells chemistries are non-flammable solid-state and LFP graphite cell chemistry. We believe these cells will be pivotal technology in the grid storage applications. Once fully deployed, we intend to integrate our conventional and solid-state cells produced using our dry electrode process into existing Dragonfly Energy and Battleborn battery product portfolio. So they have delayed the process. They've delayed production of the pouch prototype that they have shown at shows and shown to the public. So they have delayed the prototype pouches of that, but they are currently making coin solid state cells. So I'm guessing from what I'm reading here is that they are optimizing these coin cells to reduce the cost of producing a large pouch at the same time. So they are honing in on the process of manufacturing the solid state battery on these little coin pouches, and once they are comfortable and feel confident enough to go into pouch cells, they're going into that in 2027. So, and then going back up to here, so they start the pouch development in the beginning of 2027, and then later on in the third quarter of 2027, they are going to deploy that second machine to make the scalability of these pouches even greater. So that is basically everything that they have given to us. I think I highlighted a couple more things way down here. Not sure, maybe not. Yeah, this is a risk related to our solid state technology deployment. Basically saying that there's a lot of things that can affect the deployment of these solid state batteries, which we don't want to hear. We want to be optimistic and believe that everything is going to be deployed on time and the manufacturing process comes through fruition. And yeah, I highlighted this just to be aware of the risks related to their solid state technology. However, I personally choose to believe that these risks aren't going to happen. However, it's always a possibility, right? Yeah. So it's been a long video, 35 minutes of me reading. If you stuck through this, you're insane. I appreciate you for taking your time to listen to my stumbling on words, my pronunciation of words, and overall, if you got through this video, congrats to you. You're obviously dedicated to Dragonfly, and so am I. So I hope for the best for all of us. And, I hope for the best for this company. And I believe that they are in a position to benefit dramatically of the next few decades of renewable energy coming to the world. And yeah, thank you guys for taking your time if you made it through, and I hope you have a great day and a prosperous year in the stock market. All right, see ya.